Alright, today we're going to do section 2.3, real zeros of polynomial functions. We'll talk about long division, synthetic division, a couple theorems, remainder, factor theorem, and something called the rational root theorem. This is really preparing us to be able to solve polynomial functions that we cannot factor, because that's really all we've done at this point. So the first thing is just going over some division things that we need to know how to do. Long division, similar to what you guys did a long time ago in middle school and elementary, but we're going to do it with polynomial functions. So here we go. We're going to put 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. And we're going to divide that by your divisor x squared plus 2x minus 3, and we're looking for your quotient here. So what we want to do is this, is we want to kind of ask ourselves, what times x squared will give you 2x to the fourth? Alright, so what times x squared gives us 2x to the fourth? So you're thinking as x squared times something is going to equal is going to equal 2x to the fourth. So you can either ask yourself that question, or you can solve it by dividing by x squared. So what times x squared gives you 2x to the fourth? That would be x squared times 2x squared. So 2x squared goes on the top. Now the way I do long division is I line everything up. So I'm going to put all my x squareds in the same column as my x squared in my dividend. So 2x squared. So now you take 2x squared and multiply by the entire divisor here. So you have to distribute. So 2x squared, it's off to the side so you can see what I'm doing. 2x squared times x squared plus 2x minus 3. So that will give you 2x to the fourth plus 4x to the third minus 6x squared. And once again, going back to your old long division, you would multiply and then you would subtract. So if I subtract, I've got to subtract the entire quantity. So that becomes a minus. It's plus 4x cubed, so now it's minus 4x cubed. And then the 6x squared becomes plus 6x squared. So I subtracted the whole quantity. Now I can combine my like terms. This gives you 0, this gives you 0, and then your last term is plus 1x squared. Once you do that, you carry down the next term. So that'll be plus 3x. And since I have a trinomial as my divisor, I'm going to go ahead and bring down the next term, which is minus 2. Since it's going to get multiplied by a trinomial, I need to have 3 terms down there. And then I repeat the process. What times x squared gives me x squared? Well, that one's a little bit easier. What times x squared is going to give you x squared? Well, x squared times 1 gives you x squared. So I'm going to put plus 1. Once again, you can see I'm lining everything up here. So you have your x to the fourth, your x cubes, your x squareds, your x's, and your constants. Alright, so all that's lining up there. Now you take 1 times x squared plus 2x minus 3, and you will get x squared plus 2x minus 3. Subtract, so everything has to get subtracted all the way through. So once again, you get this to cancel. The next one is x, and then the next one is 1. So this is your remainder. What do you do with your remainder? Well, your remainder is what's left of the divisor. So then you have to kind of write your final answer here. It is 2x squared. Let's try that again. 2x squared plus 1 plus your remainder of x plus 1, and then that goes over your divisor. once again, just like you did, I know it's probably been a while since you've done some long division with numbers, but just like you did with long divisions of numbers, the remainder would always go back over your divisor. So here is your quotient. So that's long division. You might need to go back and watch that video again. You might need to ask questions about that long division. That is something that you're definitely going to have to know how to do on certain problems. But if we can, we're going to use something called synthetic division. This is actually a lot easier to go through with synthetic division. The thing is, it only works when you're dividing by something in the form of x minus k. So the x has to have a coefficient of 1. So in this case, with long division, we're okay with x plus 3. If you go back to the previous slide, our divisor was x squared plus 2x minus 3. So synthetic division would not work, so that's why you would be forced to do long division. Alright, so synthetic division is something you have done in the past, so I'm going to run through it pretty quickly. If you have questions, once again, make sure you ask me in class. In this box over here, okay, we want to write what x minus k is. We want the k value right here. So what would that be in this example? If it's x plus 3, then x minus negative 3, that means k is equal to negative 3. So we have this box over here, there's going to be a negative 3, that's your k value, and then you're going to write your coefficients of all your terms. But what you don't, what you need to make sure of is that every term is included. So if you're missing a term, you got to include that as a 0. So in this one we have x to the 4th, coefficient's 1, x to the 3rd is a 0, x squared is negative 10, x to the 1st is negative 2, and the constant is negative 3. Once again, you have to make sure that you don't forget any missing terms when you go to do that. Leave a little space, draw your line, and then pay attention to the process. I think a lot of you will remember this once I go through it, but you carry your first term down, which is a 1. You take negative 3 times 1. So negative 3 times 1. That's what you're multiplying. That will give you negative 3. Then you add those two numbers up, so it would be negative 3, and then you repeat the process. Negative 3 times negative 3. That's 9. Add those numbers up, repeat the process. Negative 3 times negative 1. Negative 3 times negative 1 is 3. Add 1. Once again, repeat. Negative 3 times 1. Negative 3 times 1 is negative 3. Add, you get negative 6. Now sometimes you'll see this bar at the very end. That represents your remainder. And so all of these numbers represent your coefficients of your quotient. If you started with, change colors here, if you started with x to the 4th and you divided by an x, then your quotient went down by 1. So that means this would be x cubed, this would be x squared, x, and then your constant, and then followed by your remainder. So when you write your answer, you have 1x cubed minus 3x squared plus x. Let's go back there. X cubed minus 3x squared minus x plus 1 minus 6 over your divisor. Your divisor is not negative 3. Remember, your divisor is up here at x plus 3. So all of that is over x plus 3. And there's your answer to synthetic division. Okay, so those two methods of dividing is something we absolutely need to know how to do. The next thing is the theorems. Remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is f of k, or whatever that value is that you need to plug in. So what you're looking at here, I have, once again, the same problem that we just did, and if I just want to know what the remainder is, I don't have to go through synthetic division to figure that out. I can actually just plug in f of k. So for this example, I want to know when k is -3, because remember it's x minus k. So I want to plug in f of -3. And you can do -3 to the 4th minus 10 times -3 squared minus 2 times -3 minus 3. Plug it in your calculator and see what your remainder is. Let's see what we get here. We get 81 minus -3 squared is 9. 9 times -10 is -90. Make sure you square it first. -2 times -3 is 6. And then minus 3. So we get -9 plus 6 minus 3, which will then be -3 minus 3, which is -6. And that's what we found out on the last one, is we had a remainder of -6. And so by doing this, if we just want to know what the remainder is, then we can just plug in f of k to figure out what that value is. So what is the remainder of this? We know that the remainder is -6. Okay, quick, easy way how to find the remainder. The second theorem is the factor theorem. A polynomial f of x has a factor of x minus k if and only if the remainder is equal to 0. So now right here it's saying f of k is 0, which is the remainder. That's what we just talked about. IFF, if you haven't seen that before, stands for if and only if. A lot of times you'll see that in geometry, but just in case you haven't or you don't remember. So, is x minus 2 a factor of this polynomial function? Remember, if it's a factor, it's going to lead into what we talk about in terms of the zeros. So, is it a factor? Just a quick check, we just want to see if the remainder is equal to 0. So how do we do that? Well, x minus 2, alright, remember we're looking for what k is, so k would be equal to 2, and so we're going to find f of 2. And so we're going to plug this into the function. And with something this long, I mean, it's completely up to you, but you could easily just plug this into your calculator and have it do all the math for you. I'll go ahead and write it out as we go along here. But so we got 2 to the 4th times 2, that's 2 to the 5th, so that's 32. 2 to the 3rd is 8. 8 times 7 is 56. 2 squared is 4. 4 times 4 is 16. And then we have 27 times 2 is 54 minus 18. And so if you add all that up, you will get f of 2 is equal to 0. So since we got a remainder of 0, when we get remainders of things, if 2 goes into 10 5 times, it has a remainder of 0. 2 is a factor of 10. Well, if we get a remainder of 0, then we know that x minus 2 is a factor, and I'm just going to put it's a factor of, we can call this f of x, but it's a factor of f of x because the remainder is 0. Alright, so we've done long division, synthetic division, we talked about the two theorems, the remainder and the factor theorem, and then the last theorem that we're going to talk about is the rational root theorem. If the polynomial f of x has integer coefficients, so there is some stipulations to this, if it has integer coefficients, which is really what we're typically dealing with, every rational root of f of x has the form p over q. So a lot of times you remember from Algebra 2 when someone said something, they said p over q, and you knew exactly what it was that they were talking about. That's the rational root theorem. The word rational, those are your fractions and decimals. Anything that can be written as a fraction is rational. P is the factor of the constant, so p is the factor of the constant, which would be this number at the end. and then the q is a factor of the leading coefficient. So all the stuff in between doesn't matter in terms of just identifying what these possible rational roots are. So here we go. So p is equal to the factors of the constant. So that's 1, 2, and 4. Q is the factors of the leading coefficient, which are 1, 2, 3, and 6. And so since we're actually talking about all possible rational roots, all of these include plus or minus. So not are just the positives, but we're also going to include the negatives as well. So when you list all the possible rational roots, you're going to put plus or minus on all of these values. And you just want to list all the combinations of p over q. So typically what I will do is I will just go from the first p value and then do all of the q values. So I'll do 1 over 1, 1 over 2, 1 over 3, 1 over 6. And then I'll repeat and do 2 over 1, 2 over 2, 2 over 3, 2 over 6. And then 4 over 1, 4 over 2, 4 over 3, 4 over 6. And any repeats I don't write. So here we go. 1 over 1, that's plus or minus 1. 1 over 2, plus or minus 1/2. 1 over 3, plus or minus 1/3. And 1 over 6, plus or minus 1/6. So I did all the ones and all these values right here. That's what I just finished up. Now we're going to start with 2 and do all those values right there. So now we have 2 over 1, so that's plus or minus 2. 2 over 2 simplifies to 1, so that one's good. 2 over 3 we don't have, so plus 2/3, plus or minus 2/3. And then 2 over 6 is 1/3, but we already have 1/3, so we're good there. Now we're going to do the 4. 4 over 1, 4 over 2, 4 over 3, 4 over 6. No repeats when we go to do this. So 4 over 1 is 4. 4 over 2 is 2. We already have that one. 4 over 3 is 4/3. And then 4 over 6 is 2/3, and we already have that. So this is just a list of the possible rational roots for this polynomial function. There are no other possibilities as to where the graph is going to cross the x-axis, at least not on the rational side. Okay, so these are the only rational roots that are a possibility. Now, this is our list. A little bit ago, we didn't have a list. We had nothing. So even though we have 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16 possibilities, we've went from having absolutely nothing to 16. So we definitely cut down that list. Now we have an idea as to what those possibilities are, and we'll use the remainder in the factor theorem to break down the polynomial a little bit later on to be able to identify what these solutions are. So the last example that I have for you guys on these notes is we're going to find all the roots. Up until this point, the only way we were able to find roots higher than degree 2 is if we were able to factor it. Okay, we don't have that option right now because we have 5 terms and we're not going to be able to factor them. So we're going to go through this process to be able to identify what these solutions are. So this is where we take all the information prior to this and kind of apply it to everything that we've done. So the first thing is we're going to list the p over q's. Alright, we're going to list the possible rational roots just to get an idea as to where we're at. So the p value represents the constant, which is 27. So you have all the factors of 27. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we get 9. Why did I write 2? I don't know what I'm doing. Let's go back and fix all that. Let's try that again. 1, 3, 9, and 27. And then q is your leading coefficient, which is just 1. So this is actually pretty nice. You don't have a lot of possibilities. You got plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. So when we go to look at this, we could sit here and do the remainder theorem and try to figure out as to which one of these gives us a remainder of 0, because we want to make sure that we know it's a factor, since these are the possibilities. So I could do 1, and then figure out, and I would be looking for, is it a remainder of 0? And if that doesn't work, I could do -1. And keep doing this over and over, but at this point we don't really have time to do all that. So what we're going to do is we're going to use our graphing calculator to help us simplify this process. Couple things. You have a degree of 4, so we're looking for 4 possible solutions. So when we go to do this, the graph might cross 4 times, but we also got to pay attention to complex roots. So we'll see what happens when we go to do this. Let's